Okay, given that our universal set is including 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and A is the set of square numbers, B is the set of odd numbers, complete the Venn diagram. So remember, our square numbers would be 1, 4, 9, 1 squared, 2 squared, 3 squared from here, 1, 4, 9. Our odd numbers from here will be 1, 3, 5, 7, 9, yeah? Okay, so we need to put the numbers from the universal set then into our Venn diagram. Now we can see that the number 1 belongs to both set A and B, so that's going to go in the intersection, okay, where they intersect each other. Number 2, so we go through them, yeah? Number 2 isn't in any of them, so number 2 will go on the outside. Number 3 is in set B only. Number 4 is in set A. Okay. Number 5 is in set B only. Number 6 is not in any of them, so that will go on the outside. Number 7 is just in set B. Number 8 is on the outside because it's not in any of them. And then number 9 is in the center where they overlap. Because they're in both sets. And then number 10 is, we put it over here, and number 10 is not in either of them. Okay, so then in part B, it says write down this here. So this simply means A intersection B. Okay, so that symbol there just means the intersection. Okay, so in other words, it's in A and B. Okay, so we know that's almost like the letter A, isn't it? There, so it's forming the letter A, so it's A and B. It's got to be in both of them. It's where these Venns intersect here, where they cross over each other. So quite simply, the values here will be, so we write them as a set 1, 9, okay? So yeah, whenever we see A intersection B, it's where they overlap, okay? Where they intersect each other, and the values are in A and B. They belong to both A and B. Whereas this one is the A union B, okay? So you can see the letter U there, okay? So it kind of translates to the word union. And basically that's where A and B unite, okay? They come together. So essentially it's everything that's in A and B, okay? So that set will be all of these values essentially, okay? So it'll be 1, 3, 4, 5, 7, and 9, okay? And then this means then, with the dash there, just means the complement, okay, or A complement, or the complement of A, okay? So quite simply, they are the entries, they are the elements that are not in A. So everything that's outside of A. So if you think about A, it includes 1, 4, 9, yeah, the square numbers, it's up here of course. It's basically everything else. That's what the complement of A means. So complement of A, it can't be 1 because 1's in A, but it can be 2, it can be 3, it can't be 4 because 4 is in A, but it can be 5, 6, 7, 8, and of course then 9 is in A, so we won't include that. And of course then 10 as well is outside of A, so we've got to consider all these values out here, okay? Because they're all the values outside here and these values that are not in A. So everything that's outside of A. And similarly then with this here, B complement, so it's everything that's outside of B, okay? So B complement, everything outside of B. So all of these things are inside B, so we'll ignore them, it's everything else. So 2, 4, 6, 8, 10. Okay, so essentially it's the even numbers, isn't it? Okay, because B is the odd numbers, so B complement would be the opposite, so they would be the even numbers. Finally then, A union B complement. Okay, so we remember earlier what A union B was. A union B was when A and B are united, so it's all of them together, but now we want the complement, so we don't want these essentially, we want everything else. So we know this is A union B, all of that there, but the complement, the dashed outside the bracket, will be everything outside. So that'll be 2, 6, 8, and 10. Okay, So it'll be A union B complement. Now it'll be 2, 6, 8 and 10.